Hello everyone. In this video, let's solve a numerical problem which deals with the distribution of error to the field measurement. As all of us have learnt about, there is something called as a closing error in the domain of error and accuracy. The closing error seems to be distributed among the observations, and the closing error is then distributed to the various observed quantities as per certain rules. The first one says that the correction to be applied to an observation is inversely proportional to the weight of the observation. There is another rule, second rule, which says that the correction to be applied to an observation which is directly proportional to the kind of a square of the probable error. And the third rule says the correction to be applied to the line of levels is proportional to the length of the root. Now with this, let's try to solve this numerical. The problem statement says adjust the angles of a triangle of which the observed values are angle A, angle B, angle C are given, and their weights are also given. For angle A, the measurement is done by considering weight equals to 3. For angle B, the weight is 1. Angle C, weight is equals to 3. So the scheme of solution is really simple. First, let us try to adjust the given values based on the very simple thumb rule saying that A plus B plus C should be equals to 180 degrees. Let's try to find out the error first, and based on that error the corrections are to be identified. Okay, so A plus B plus C seems to be 180 degrees 0 minutes 3 seconds. We have some 3 seconds excess, and this excess is nothing but the error. Now how do we distribute it? We say that CA, the correction for angle A, CB, the correction for angle B, CC is the correction for angle C. We write this statement saying that the CA is proportional to 1 by 3, CB is proportional to 1, CC is proportional to 1 by 3. So the weights are 3, 1 and 3 respectively here. So CA is to CB is to CC should be equals to 1 by 3 is to 1 by 1 is to 1 by 3. Further, this could be simplified. I mean, by multiplying 3, it would be 1 is to 3 is to 1. So that would be equals to CA is to CB is to CC. At the very same time, from this very basic relation, one could write if CA equals to CA, CB becomes equals to 3 times CA just by considering two statements at a time, and CC is also equals to CA, and you should remember that CA and CC had the same term which is written on the numerator. Okay, so the error was 3 seconds, whereas the correction is minus 3 seconds. So the total correction is minus 3 seconds. That is the kind of a total summary that you would get out of this equation. CA plus CB plus CC is equals to minus 3 seconds. Okay, now what is CA? CA is CA by keeping CA. CB in terms of CA is 3 times CA. CC is CA. Now let's make such substitutions to this equation. So you would end up with CA. What is CB? 3 times CA. CC is CA. So you have the very unknown, which is CA, correction for angle A. So you have about 3 CA, 4 CA, 5 CA, which is equals to minus 3 seconds, or CA is minus 0.6 seconds. Now moment you get the value of CA, it's very easy to calculate the other values like correction for angle B and correction for angle C. Okay, so CB, uh, uh, going back to the basics of the equations which are transformed. CB is minus 3 into zero point 0.6, which is minus 1.8 seconds, and CC, which is anyhow equal to CA, is minus 0.6 seconds. Okay, now let's try to apply the corrections. We know all corrections. CA is 0.6 seconds with the negative. The error was positive, so the correction is negative here. And then minus 1.8 second, which is correction for angle B. Correction for angle C is minus 0.6 seconds. So we would deduct such fractions from the values observed in the field, and that's how we would end up with the corrected values, which are nothing but the adjusted values. And if we could add all of them, we are getting a value of exactly 180 degrees. Thank you. Hope you have understood.